Good morning, everyone. So today's presentation is evolving memory role in future mobility. So I'll be talking to around 30 to 40 minutes from here. Okay, so let's start with the first slide. Okay, so when we talk about mobility, so we have four growth pillar in future mobility applications. We call it as case, that is connected vehicle, which is nothing but if you know that in the future the automobile industry is working to connect your car with surrounding objects, vehicles, infrastructure, or whatever is there in surrounding to your vehicle when you are on the road. Same time, they are working on ADAS system, that is advanced driving assistance systems and autonomous cars, share device, and electrifications. So the innovation is happening at tremendous speeds. Okay, so when we want to achieve these four things, then we have to, of course, do lots of design in software side and hardware side. So when we talk about hardware side, so vehicle architecture is transforming from today's architecture, is which is not fit for future mobility, which is nothing but which is for low bandwidth and flat network, which consists gateway, and the gateway will control your ECU for different purpose. But in the future, or the one we are working for tomorrow is with central gateway, and the central gateway, instead of controlling ECU, it will control different domain controller. The domain controller can be for EV or powertrain connectivity, connected infotainment device, or ADAS system, or autonomous feature, or body and comfort control, e- control ECUs. Okay, so for this feature, you need high bandwidth network. And moving forward, that there is a developing ongoing, that there is a concept also that we will move on central computers concept. And in central computer concept, that we are not going to have central gateway, we'll be having high performance computer to make this to reduce the hardware complexity. And instead of a domain controller, we are going to have zonal gateways, which will control multiple engine control units. Okay, and there are some concept coming up that central computer won't be loaded on your car in future. That will be placed at the supplier side, and from there they will control your zonal gateways, the zonal gateways. So that will help us to reduce the complexity of the hardware design of the car, and reduce the weight of the car. So tomorrow we are working with low bandwidth. Soon we are going to have required for high bandwidth gateways, and then we are moving forward to central computer concept, or maybe the central computer will be not loaded in the car, it will move away from the car to a specific place by your supplier or OEMs, car OEMs. Moving to next slide, there is another same thing, same architecture explained by another source, that current architecture what we are using for the car, it is for patch architecture, which can support up to 100 ECU and limited computing power. And each ECU's engine control units functions are isolated to each other, and lots of wires are there, and limited cloud-based functionality can achieve with this. So, but what we need now as a user, we need pleasure, safety, and convenience. So we are moving towards function-defined architecture, which needs significant computing power, and function defined not just by hardware or ECU, it's by software. So hardware will be abstractions in future, and there is will be reducing the wire, and that your car will be always connected. So user expectation is more IoT device, or you can say IOV, Internet on Vehicles. Moving to next slide. So I in the previous two slide I talk about the car gateways. So there are some benefit of the car gateways, but there are some limitation. For if we want to achieve autonomous driving, the car gateway is very necessary. But they are getting complex. Same time they are getting more powerful, and they are getting more software driven. So here is a one example of a central gateway, which is going to be our tomorrow. Central gateway is infotainment domain. In vehicle experience domain, it can control like infotainment, audio, front display, rear display, and amplifier, speakers. And similarly, you have like for autonomous car, you need lots of sensor ECU, which are will be under like driver replacement domain, body and comfort domain, then powertrain and vehicle and dynamic domains. To achieve these kind of solution, you need to go through lots of key connectivity solution like CAN, LIN, FlexRay, and Ethernet. So as per now, like the maximum speed we can achieve through Ethernet to transfer data or to control your gateways and domain controller over Ethernet, and speed is 100 megabit per second to 1 gigabit per second. So there are some limitation right now on bandwidth. So bandwidth is one of the limitation in the future with more advanced sensor, which will be equipped on your autonomous car or self-driven car. But as I mentioned, there is some benefit of the gateway because the gateway can control your car. Okay, so it can give you intelligence trash control when you are on curve, and it can help you to protect from the bump on the roads. Intelligent car and engine brakes. So once there is some obstruction comes in your on the way to your vehicle, then your speed will be de-accelerate using by automatically by car, which can give you smooth drive all the way. So so far I just talk about hardware, but there are some changes are happening hardware, and we required hardware change because we need extra features. So right now, if you talk current vehicle will be like some electronics device software and some system integration. Let's say cluster are connected to your phone or other devices, or your cluster or engine control unit are controlled through software. But in future, it's going to be more complex, but functionally it will grow. So in future, the car will be not just limited with electronics device or some software or system integration. It will go for software maintenance over OAT, as you are using right now your phone, right? So phone software will be get upgraded periodically. Similarly, in future, software maintenance required for the car, and new feature and function will be added, and then some cloud service will be added. So back in 1980, we started like for when we talk about software, we just need software for some engine controller, and we move to infotainment, engine controller, passive safeties, and securities. Similarly, we started to grow slowly, and now if you see that lots of demands are there for software, and software share in the vehicle are increasing exponentially. So as of 2020, we need like ADAS system, infotainments and user experience, body security, connectivity on your car, and engine control. So in future, it's not just hardware is important for your car or your vehicle. Software will have also share in the vehicles design and development. Here are some example for software platform development and joint development. If you see Tesla, so Tesla is working for Model 3 and Model Y for different processor, Intel Atom for Model 3 and AMD processor for Model Y to achieve OTA and appearance mode for navigation, entertainment, and system maintenance. And Tesla is also targeting software revenue. So if you look at this slide, so here if you see that as per 2029, so 3% revenue for Tesla was from software sales, and they are targeting to achieve 14% by 2025 by selling this kind of package for software, auto optional package, OTA upgrade optional package, advanced IOV service. So this is already in the pipeline for Tesla device, which is going to be followed by each and every car manufacturers. So similarly, Volvo and Polestar also working with Qualcomm to upgrade their feature like system, Google Voice Assistant, map update by OTA. Sony has set up new company recently. This is a big revolution for automotive industry. Sony Mobility have established new company just to work on 5G communication, OTA, and remote control for automobiles. And these are the two models which they are working for right now. So when you talk about like hardware and software things which we need for future, so of course you need lots of controllers, microcontrollers to achieve your goal. So here are the list of few microcontrollers which are already in mass production right now with by different vendor like NXP, TI, NSS, ST Micro, Infineon, with different DRAM interface and density, and to perform different tasks like let's say gateway ASIC or general purpose gateway solution. If we talk about NXP i.MX6, so it have DRAM interface of DDR3 and can support density 1 gigabit to 4 gigabit. Similarly, Renesas, ST Micro, Infineon, they are loaded with LPDDR4 Hyper RAM with density 4 gigabit, and for Hyper RAM 64 megabit to 256 megabit. Moving to next slide. So in the previous slides, I talked too much about OTA, so I want to explain here what is OTA. OTA is over the air update. So the software will be used for lots of future for your automobile, your vehicle and cars. So that should be upgraded over the air from the cloud suppliers and software supplier. The purpose for this OTA will be to software and driver upgrade, efficiency and interface investment, and error feedback and correction for the software and driver. So to achieve this OTA, your device should be equipped with telematics control unit or vehicle infotainment, car gateways, OTA management, or engine control unit memories for autonomous service. And all these solutions are for all these solution we have our support for memory, for flash and DRAM. Apart from that, when you are doing all these three activities over the air, you must need some security. So security is like identification of the device or data or code, and authorization is required. So to protect your OTA feature, we have security flash. So I will talk about this flash in onward slide when we talk about our products. So we are providing complete solution for OTA features. So here are some example for connected vehicle to everything. Like when I say there are four things: connected car, ADAS, and autonomous shared device and electrification. So connectivity will be the future for all the cars. Like if your car should be connected to everything to achieve autonomous or self-driving in future, like to home B2H or B2B, like home and building, B2G, to connect to your grid, connect to your device, connect to pedestrian, connect to vehicle, connect to network, connect to infrastructure around, surrounded by you when you are on the road. And the growth of this feature is roughly CAGR 30% in current period of time. So here is the example of the detailed example of your connected car, and why we need connected car. We need connected car for road safety. Let's say that you have you are connected to your neighboring car and like infrastructure and special vehicles or network or pedestrian. So your car is connected to each other, and each car communicate to each other if any emergency happen, or they can see any emergency vehicle through the surrounding cameras, and that view will be transferred to you through cloud or through network or to all the cars in that areas. So when we talk about road safety, let's say if you have any hazardous happen, any accident happen, so this car can get the update to the server through their camera, and that server can transfer data to the car which cannot see this accident Okay, and same time, like if you have any emergency vehicle passing by, so these kind of information will be given to your cars. Okay, and using the connectivity V2N and V2D, like carpool service will be upgraded, and it will be more easy to achieve the goal for carpool service. Similarly, like iTaxi, which are app based, so everything will be controlled through this to make it more efficient, road safety, traffic efficiency, and energy savings. So I just give you very basic how is going to be your car display in the future. Let's say if you are on this car and your car, and they you want to take right turn. So there is a pedestrian here, but you cannot see because of this building. But surrounding camera can see this pedestrian, and they can indicate to you on your dashboard like this. Or any accident happen, it can display on your cluster like this way. So similar, if any error is occurred around in surrounding your car, it can display to you over your cluster or on your display. Okay, so next is ADAS system. Of course, to achieve like self-driving, you need ADAS system, advanced driving assistance system. And for the advanced driving assistance system, there is a here is a small architecture. Like you have sensor microcontroller which control graphic processor to display information, control connected to power controller to control your transmission and engines, safety domain controller for your brake, automatic advanced braking system, and steering controls. And these sensor controller are connected to lots of sensor modules or smart sensor for edge computing like camera, lidar, radar, and ultrasonic. So in future, like sensor is going to be highly critical component for to achieve ADAS system. And this is like if you talk about sensor, so as I mentioned in the previous slide, there are four sensor, either is camera, radar, lidar, ultrasonic. So each sensor have some limitation. Let's take one example, like soft object, like example is timber, cannot detect reliably by radar sensor. Okay, or low standing sun can fade the video sensor. Similarly, tunnel in entrance can affect the radar and video sensor. So, and there are some other limitation like bad weather cannot handle by your camera, whereas radar can handle it. Overcome a bad light, you can use again radar. So similarly, there we have to go with multiple sensor in on board. So every autonomous vehicle is going to be have some combination of your sensor. So if you look at this table, like object detection, or either object classification, or distance estimation, object edge precision, or land tracking, range of visibility, functionality in bad weather, functionality in poor light. So each and every camera have some advantage and limitation. So we must need to go with the combination of lidar, radar, and camera. So in the future, like sensor is going to be a play critical role, and to control this sensor and functionality, again the bandwidth will be the criticals. Let's, as I mentioned, like ADAS system. So there are some SoC already in the under development or in the market to support your requirement. As of now, if you see NVIDIA or in 2254 is available in the market. 254 TOPS means uh, trillion operation per second. So this is available right now, and NVIDIA is working on even faster processor, that is Atlan, which can process with 1,000 trillion operation per second. Similarly, Qualcomm is working on their IC Snapdragon Ride Vision, which they are about to launch in 2024. With this processor, they claim that they can achieve driving, self-driving, autonomous driving level 2 and 4. Whereas like Mobileye also working on their micro SoC, that is IQ Ultra, which runs with 176 trillion operation per second, and that they are about to launch this part in 2025, which can achieve self-driving level 4. So lots of SoC microcontroller are already in either launch or in R&D stage to achieve your software and hardware requirement. Either it is related to car gateways, or either related to connectivity, or related to ADAS systems. So let's see some example of self-driving vehicle which we have right now. So this is the first example, robotaxi, which is self-driving vehicle already under test in China. It is 7-passenger cross SUV. And then this is iCrystal. It is shuttle bus for 17 passenger. And another self-driving is like for UW transportation, is self-driving autonomous car for transportation for your dog, your uh, cargoes and other functions. So they are planning to launch this vehicle in by end of 2020 year this year, and forecast over 50,000 vehicle in 2028. Here are more example of self-driving and either self-driving vehicle which are also shared device like Uber. If you talk about Uber, Uber is like app-based shared car, but it is not self-drive. So here are some example like Cruise, Jumex, Didi, Ox, Botica, Pony, and Autox. So Cruise is the only one right now in function in some part of Europe and USA in limited areas, which is nothing, which is self-drive shared device. Okay. Now let's move to e-bike. When we talk about uh, evolution, then lots of evolutions are happening in e-bike. So if we just talk about like European market right now, so they are planning to sell by 2020-30. They are planning to sell 30 million unit of bicycle, and which will be greater than the normal bike in future. Here are some forecasts for Europe market e-bike forecast, which is like 2020 e-bike will be 4.4 million, and in 2030 e-bike is going to be around 15 to 16 million. Whereas another forecast is like globally 165 million unit bicycle is available right now in 2020, which is about 30% electric. Total bikes is 165 million, but 30% is electric, which is about 15 million e-bike is already in the market right now globally, and it is forecast to be achieve 68 million unit by 2025. And when we talk about like e-bike, so e-mobility is not just limited to e-bike or car or your vehicle. It can be used for other purpose as well. Let's take some example. Uh, E-bike and a smart food runner for your food court. Then you have food delivery trucks, and then you have autonomous moving robot for your warehouse industries and other heavy duty applications. So it's not like e-mobility or future mobility will be only limited to your car. It can be used for multiple applications as well. Now, when we talk about future trend, as I mentioned earlier in the first slide, we are also going to electrify our car. So electrification is happening with tremendous speed right now. We are moving from combustion to electric car. So as of 2015, 100% car or 100% vehicle on the street, on the road was IC cars. But it is we are working toward to achieve 50% of battery electric vehicle car by 2030. So to achieve this, lots of government for different country are pushing and making their lots of policies. So if you see, like Norway is the first country to forbid IC car in 2025. Similarly, other countries like Germany, UK, US, everyone have set some deadline to forbid the IC car and move on completely battery electrical vehicle. And there are some product already, all vehicles are already launched by key manufacturers like Mercedes-Benz have already introduced 6 new EV by 2020. Volkswagen and Renault already have crossed the sale of Tesla in Europe. UK already planned to stop all gas and diesel run vehicle by 2030. European market is targeting 30 million EV by 2030. General Motor to sell only just EV starting 2025. Toyota and Honda is a little bit late in the EV market, whereas China BYD cars are overtaking Tesla as world's biggest EV producer by sales right now. And here are when electrification is happening, there are new things are also happening. The new things are what is followed by electrification is digitalizations, and lots of car companies are using recycling materials, and they are improving their infotainment for EVs. So if we talk about digitalization, so Mercedes-Benz are coming up with hyper screen. So most of their new models will be loaded with hyper screen, which you can see as an example here. So this is one model for Mercedes-Benz, which have 56-inch covered glass extended from instrument clusters. This is a big revolution right now for digitalization. When you talk about raw materials improvement, so if you see iVision circular by BMW, so they made this car from 100% old materials and renewable raw materials. Same time, they are also working on digitalization, so they have equipped their car with 3D print of cluster instruments. So here is the view of their cluster. So its cluster dashboard is consists of one 12-inch digital instruments cluster and one 14.9-inch touch screen infotainment system. So another advantage is that when you are transforming from one type of vehicle to another type of vehicle, you have chance to do lots of things to do. So Volkswagen are working towards fully electric car, and they forecast to achieve it by 2025. But same time, they are working on natural and recycled material. If you look at this car, so this car is most of the part for this car are made of wood. So the coat of this body work is wood chip are used as a natural coloring agent along with bio-based hardener. And another thing, if you see here, the roof of this vehicle is 100% made of 100% recycled PET bottles, and some dashboard and your interior design is done by wood. So this dashboard or your uh, window partition are made by woods. So it is almost 70% recycled material are used for this car. And that your tire also has been changed right now by Volkswagen. They use bio oil, natural rubber, or rice husk to construct this tire, which is 100% natural and recycled materials. So when you are going for electrification, you must need to charge your car. So lots of new things are happening for e-charging, and its growth is tremendous right now. So if you see that industry already almost have in enough investment right now, and it is targeting to achieve investment of $50 billion in three main reasons through 2030 to meet the requirement of the charger. That when I talk about three growing reason, biggest reason is Europe, China, and United States. So lots of new things are happening for EV charging field also. and is not just limited to EV e-charger are not just limited to your EV charger. It now become more smarter than just EV charger. It is bi-directional storage between the vehicle and to your home or to your like bus station or railway stations, or your any space which you share with a battery charger. uh, Either it can be your store or your garage or your supermarket. So with bi-directional storage you can achieve, you can use your battery which is charged through either through solar power generator or standard power supply, and you can discharge power from the battery to your car or for your other purpose. As I mentioned earlier, it can be either your home or your garage or your supermarket. Okay, and the advantage of this bidirectional storage and charging station is that if your battery is fully charged for your car but you don't want to use your car, you can again discharge back this to your battery, home battery, and this home battery can use for other battery energy can use for other purpose, either for your home garage or uh, charging stations or your any place you have equipped this charging stations. So this, to achieve this, we also need to do lots of hardware and software changes. So let's talk about current automotive market. So and memory IC forecast. So if you see the current market for last 3 years and current like 2019, 2021 for each key supplier of automotive. So the share of battery operated car, EV car are increasing and increasing very fast. So at the same time, the demand of memory, either it is DRAM or flash, are increasing, which you can see here from this slide. And we are estimated to grow with CAGR 14.65%, 14.6% for DRAM and flash demand in the future. So when we talk about either central gateway or ADAS system, self-driving or EV charging or any e-mobility, so of course you need hardware change as well as software. So you must need to do lots of need lots of space to keep your software. So Winbond is the one who is providing complete solution for each and every application. Either it is for ADAS, for camera cluster, or gateway, or navigation system, or V2X, or your car is equipped with other applications like audio, EV management, battery management, or powertrain, wireless charging on board on your dashboard, infotainment system, other telematics unit. So you must need to have various range of NOR flash. So we provide NOR flash from 2 megabit to 2 gigabit right now, and to improve your performance as well as economically, to make it more reliable, we have QSPI NAND which can support 512 megabit to 2 gigabit. SLC NAND can support up to 8 gigabit, and we have octal NAND flash from 1 gigabit to 4 gigabit, octal NOR flash 512 megabit to 2 gigabit. Let's take this example, like if you talk like infotainment need wide range of software. So based on your feature added in infotainment, either you can use lower density NOR flash, and if you need higher density, you can still use our NOR flash. But if you want highly economic solution, price benefit, you can go for our NAND flash as well. And apart from that NOR flash, we also have to work for OTA application, because OTA application is going to be featured. So when you need OTA over the air update is in progress, you hope that update you can update the data very fast, and concurrent operation to be performed and resume from suspended task. So to achieve that, we have one solution, that is SPI stack flash, which is nothing but two NAND flash or two NOR flash in single die. So joined with two flash, there is a one flash which is SPI stack. Either it can be a parallel to NOR or parallel to non NAND, or a combination of NOR and NAND. So using this stack flash, one flash can use for the task you are performing right now. You don't need to wait to upgrade your firmware or your data over the air, because the another parallelly connected NOR flash or NAND flash can perform that task. So at the same time you can perform OTA upgrade as well as you can perform your task, other tasks. You don't need to wait for to upgrade your software or your firmware. Apart from that, like we have NAND flash IC, which we can support for ADAS sensor. So as I mentioned previous slides also, that we have an octal NAND. So 4 gigabit octal NAND can support for SoC programming code. 2 gigabit octal NAND can support for event data recorder. And for car gateways, we can support 256 megabit serial NOR flash for system boots, 8 gigabit SPIN for data or log storage. Apart from that, I earlier mentioned for in the OTS slide that when you are performing your task, you must need security recognition and authorization. So for that, we have also worked for security level of the ICs. So we have a very basic IC that is SPI NOR flash 250 W25Q NOR flash series, which is very basic security level for general purpose. But we want substantial security. You can pick our W77Q series that can support, that is compliant with ISO 26443 safety feature. And when you want like high security, you can choose W75 series. This all microcontroller are all memory performs same function, same code storage flash series, but with extra memory, extra security compliance are there. And when you talk about these two, W77Q and W775F, these two memory have inbuilt microcontroller which can help you to generate 4 key password to protect your code inside the memory. So if anyone wants to access or want to do some change in the code, the basic code must need to input the 4 key password. So we are working for complete solution when it comes to security levels. So here are like our DRAM products, what we are supporting right now. So whether you need cluster or infotainment, telematics, ADAS or V2X or car gateway, either central gateway or domain controller. So we have complete solution of DRAM from 16 megabit to 8 gigabit with different interface. Either it is SDR, DDR, DDR2, DDR3, or it is low power DDR, low power DDR2, or you hyper RAM. So we provide complete solution for your most of the application which are required for the evolution future e-mobility. So let's talk about our engagement. Like we are engaged with automotive industry since 1984, when your car used to equip with just audio or radios. So slowly we are moving from audio radio to infotainment, instrument, ADAS, and connectivity car. And right now we are working with most of the tier 1 manufacturer or supplier for automobile OEM for connected car, ADAS, and instrument clusters. We also support ACQ 100 qualified part or JEDEC automotive standard qualified part. And as I mentioned in the previous slide, we are also compiled with security function standards like ISO SAE 21434 and ISO 26262. So here I would like to again introduce our cyber security and functional safety compliance. So in 2020 we got certificate security cyber security related certificate, that is SAE 21434, and Winbond is the first memory company to achieve this certificate. Apart from that, we have a functional certificate that I also mentioned in the previous slide, that is ISO 26262. And as a Taiwanese company, we are the first company in Taiwan to achieve this certificate. Okay, so for DRAM side, when you talk like DRAM, so we are working toward, we also consider for nature, so we working towards power consumptions. So we have ultra low power device, whether it can be 64 megabit hyper RAM or hyper RAM or 256 megabit hyper RAM for different voltage. Either it can be 1.8 volt, 3 volt. Similarly, we have another low power devices which can support with low power by hybrid sleep mode, and it also provide design simplicity and space saving by the count pin. So these are the product which we have for different application, and automotive will be also supported for this by this product. So by our continuous technology migration from one product to another product, one interface to different interface, and from uh, normal 3 volt device to 1.8 volt device or 1.2 volt device, we are continuously contributing in energy saving. So we have estimated that by supplying our DRAM to the global customers, we have saved about in 2020 we have saved about 648 million kilowatt per hour energy. Okay, so this is my final slide. So today's like takeaway is that car to achieve the electrification or future mobility, car architecture are transforming from distributed ECU domain to domain or zone architecture, and connected car OTA function and ADAS enable service consists to enhance user experience, whereas where cyber security and functional safety is key topic. Power management will become critical for the new design by new type of memory and processor, because lots of new development are happening in microcontroller supplier and memory supplier. System architecture become more powerful and complex. Edge processing to a system assist might be solution to achieve the robust performance. And Winbond have DRAM and flash assist computing and storage for all different application in mobility. We can continue to support customer and contribute to industry to providing suitable semiconductor to enrich humans' life. That's all from my side. So if you have any question, then you can reach to me through my email ID as well.